UrbanSquare is an innovative tool that leverages the capabilities of Destination Earth to empower urban planners and decision makers in addressing climate-related challenges. The UrbanSquare tool comprises key components, each addressing a critical aspect of urban climate risk: air quality, urban heat, sea level rise, flooding, and resource demands. These components have been developed by 3 companies: Murmuration, Systema, and Mosaica. This tutorial will guide you through each of these components, providing a comprehensive introduction to the UrbanSquare tool and its applications in urban climate risk assessment and management. To access the UrbanSquare landing page, a Destination Earth account is required. The page includes a link to the project's GitHub repository, where users can find the source code and additional documentation. A list of thematic components that the user has permission to access is displayed. These components are organized by location. For example, here we have access rights to the air quality and urban heat components in Toulouse. On the left, we see a map displaying nitrogen dioxide pollution at a 1 kilometre resolution. This data is derived from a model developed by Murmuration, which enhances data from the Copernicus Atmosphere Service. In the top right corner, there is a graph showing daily nitrogen dioxide concentration levels. At the bottom right, we have an overview of the key factors influencing pollution in the area. To focus on a specific period, we navigate to the Settings panel. First, we select the variable to be displayed on the map, either nitrogen dioxide concentrations in the air or the number of polluted days over the chosen period. Here, we choose the latter. Next, we select the period of interest, considering the entire year 2023. For temporal aggregation, we choose a monthly view to get a broad overview. We can also select the applicable regulatory standard. Currently, the tool includes both World Health Organization and French Health Agency standards, but additional standards can be incorporated. We can zoom in on a specific area within the city. We will explore that option later. Now, let's confirm these settings. The map is generated dynamically and displayed in real time. Looking at the graph, we see that at the city-wide level, pollution remains well below the World Health Organization threshold. However, certain areas appear more polluted than others. Let's select one of these areas for a more detailed analysis. In this specific area, nitrogen dioxide levels exceed the World Health Organization threshold, primarily due to the concentration of major roads. Now, we will configure with a new analysis. We keep the same variable, but focus on a shorter period, selecting daily aggregation for more detailed insights. Additionally, we specify a location: Blagnac, a suburban area of Toulouse that hosts the international airport. The data shows nitrogen dioxide pollution levels in Blagnac well below the World Health Organization threshold, with slightly higher levels in the western part of the city. Pollution is relatively uniform across the area. By clicking on this specific zone, we can perform a more detailed analysis. Here, we observe that on certain days, nitrogen dioxide levels exceed the World Health Organization threshold. The urban heat component is designed to illustrate thermal dynamics in urban areas, including measurements of air temperature and land surface temperature. At the top, there is a map of the area of interest, accompanied by a settings panel to configure the displayed information. At the bottom, we have a graph showing the seasonal variations of both air and land surface temperatures, and a bar chart displaying the distribution of land temperature classes across the city. Various variables can be displayed on the map. Let's visualize the raw land surface temperature during summer 2023. The tool allows for neighborhood-level analysis, enabling comparisons between different time periods. I select the raw surface temperature variable and focus on the neighbourhood of Saint-Michel, an area in Toulouse known for its greening efforts in recent years. We will compare data from summer 2015 and summer 2023. The temperature profile in this area has noticeably changed between these two periods. Let's check the classified map to confirm this observation. We can also display the urban heat island variable, which highlights the hotter areas in the city. The visualization confirms that the northern part of the area is no longer affected by the urban heat island effect, demonstrating the positive impact of urban greening policies. The flood simulation component is freely available through the Destination Earth platform, demonstrating federated integration with the Intelligent Information Infrastructure for Water Resources Management of Mosaica, ISME Hydro. The user specifies an increase of water level and an initial point for the flood on the map. The simulation takes place in real time, taking into consideration the elevation of the riverbanks and the land profile. The flood field is displayed on the map. This is an area on the lower stream of the Danube, critical for the navigation sector around the city Schwischdorf. The map also shows the land objects, the buildings and the infrastructure in the area of the flood field. This is a step towards the estimation of the flood damages. The simulation results in also showing the number of buildings, roads and forests affected by the flood. The flood simulation has global reach. We can select another river in another area in Europe. To make it easier, the base map can be changed. The example shows a flood on the river near Kočanica in Croatia. To see the flood better, we have changed the base map to imagery. The Global Inundation Risk Service allows you to assess the effects of sea level rise and storm surges by running different long-term climate scenarios using the panel on the left. The Info button gives a detailed description of each parameter you can select: the confidence level, the SSP, the year, and the storm surge height. The climate scenarios are produced based on the sea level rise projections developed by the IPCC. The inundation layer can be visualized over the default satellite map or the street map. The 30-meter resolution map highlights flooded areas in red and marks in green the regions that, as of 2020, are protected by artificial or natural barriers. You can also check the effects of inundation on a specific area of interest. First, you draw the polygon, then you click on Run Analysis. The smaller the area, the quicker the process. The panel opening on the right-hand side of the page shows 3 types of information. The exposure assessment gives you insight about the number of people affected by the flood, as well as the urban and cultivated areas potentially impacted. You can then request to see if there are any critical infrastructures intersecting the area of interest. There are different categories included here: energy systems, emergency response infrastructures, educational buildings, and healthcare facilities. Finally, a statistical analysis can be run to investigate how sea level rise impacts coastal cities and their population over time, or in terms of climate scenario and storm surge height. These statistical charts can also be downloaded. To maximise its potential, UrbanSquare will focus on building trust through demonstrable accuracy, leveraging a wide range of datasets, and maintaining ongoing stakeholder engagement. By providing information, facilitating knowledge exchange, and offering training, it ensures that users can fully harness the capabilities enabled by Destination Earth.